ground rod cannot be used in the described situation for several reasons. Firstly, it's an electrical code violation. According to the National Electrical Code, ground rods must be used to create a grounding electrode system which provides a path for fault currents. They should not be used as a substitute for equipment grounding conductors, which are the green or bare copper wires in a standard electrical cable. Secondly, it creates an improper grounding path. Wiring a ground rod to the washer and dryer duplex receptacle only provides a grounding path for those specific circuits. It does not provide a grounding path for the entire garage, including the other 2 wire circuits or the house. Thirdly, it offers limited protection. Even if it were possible to use a ground rod in this way, it would only provide minimal protection against electrical hazards. A proper grounding system must be installed throughout the entire building, including the panel, electrical outlets, and appliances. The correct solution is to install new 12/2 NMB cable, which includes a ground wire from the electrical panel to the garage. This will provide a safe and effective grounding path for all electrical circuits in the garage, including the washer and dryer receptacle. Grounding is a critical safety component of electrical systems, designed to protect people from electrical shock and prevent damage to equipment. It provides a low impedance path for fault current to return to the source, allowing the overcurrent protection device, such as a circuit breaker or fuse, to quickly interrupt the circuit. A proper grounding system consists of several components working together. These include the grounding electrode system, the equipment grounding conductors, and the bonding of metallic parts. The grounding electrode system typically includes ground rods, ground plates, or underground metallic water pipes, all connected to form a low-resistance connection to the earth. Equipment grounding conductors are the wires that connect the metallic enclosures of electrical equipment, such as appliances and outlets, back to the electrical panel. These conductors provide a path for fault current to flow back to the source, tripping the circuit breaker or fuse. Bonding is the process of connecting all metallic parts of the electrical system together, such as metal conduit, enclosures, and water pipes. This ensures that all metallic parts are at the same electrical potential, reducing the risk of electric shock. Using a ground rod as a substitute for proper equipment grounding can create a dangerous situation. If a fault occurs in an ungrounded appliance or circuit, the fault current may not have a low impedance path back to the source. This can cause the metallic enclosure of the appliance to become energized, creating a shock hazard. Additionally, the fault current may not be high enough to trip the circuit breaker or fuse, allowing the fault to persist and potentially cause a fire. In the scenario described, the house and garage wiring are mostly 2-wire, meaning they lack a dedicated grounding conductor. Adding a ground rod to the washer and dryer circuits in the garage does not address the fundamental lack of grounding throughout the rest of the electrical system. It's like treating a symptom instead of curing the disease. The proper approach is to upgrade the wiring to include a dedicated equipment grounding conductor. This can be achieved by running new 12/2 NMB cable with a ground wire from the electrical panel to the garage. This new cable will provide a safe and effective grounding path for all electrical circuits in the garage. When installing new wiring, it's important to follow all applicable electrical codes and regulations. This includes using the correct size wire for the intended load, properly securing the cable, and making sure all connections are tight and secure. It's also important to properly bond all metallic parts of the electrical system together. This includes bonding the metal enclosures of the electrical panel, outlets, and appliances, as well as any metal conduit or water pipes. Bonding ensures that all metallic parts are at the same electrical potential, reducing the risk of electric shock. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. A qualified electrician has the knowledge, skills, and experience to safely and effectively install new wiring and grounding systems. They can also ensure that the work complies with all applicable electrical codes and regulations. Furthermore, consider the limitations of a single ground rod. The effectiveness of a ground rod depends on several factors, including the soil type, moisture content, and the depth to which the rod is driven. In some cases, a single ground rod may not provide a sufficiently low resistance to ground. The National Electrical Code specifies requirements for grounding electrode systems, including the number and type of grounding electrodes required. In many cases, it is necessary to install multiple ground rods or other types of grounding electrodes to achieve a sufficiently low resistance to ground. Even with a properly installed grounding electrode system, it's important to remember that grounding is only one part of a comprehensive electrical safety plan. Other safety measures, such as ground fault circuit interrupters, GFCIs, and arc fault circuit interrupters, AFCIs, are also important for protecting people from electrical shock and preventing fires. GFCIs are designed to detect ground faults, which occur when current leaks from an electrical circuit to ground. When a GFCI detects a ground fault, it quickly interrupts the circuit, preventing electrical shock. AFCIs are designed to detect arc faults, which are dangerous electrical discharges that can cause fires. When an AFCI detects an arc fault, it quickly interrupts the circuit, preventing a fire. In summary, using a ground rod as a temporary grounding solution for ungrounded circuits is not recommended. It's unsafe, violates electrical codes, and provides limited protection. The proper solution is to upgrade the wiring to include a dedicated equipment grounding conductor and install a complete grounding system that complies with all applicable electrical codes and regulations. Always prioritize safety when working with electricity and consult a qualified electrician if you have any questions or concerns. The grounding system is not only about safety, but also about ensuring the proper operation of electronic equipment. Sensitive electronic devices can be affected by voltage fluctuations and electrical noise. A good grounding system helps to minimize these disturbances, providing a stable and reliable power supply for electronic equipment. Proper grounding helps protect against lightning strikes. While a grounding system cannot prevent a lightning strike, it can provide a path for the lightning current to flow to ground, reducing the risk of damage to the building and its contents. In areas with frequent lightning activity, it's especially important to have a properly installed and maintained grounding system. The National Electrical Code, NEC, Article 250 provides detailed requirements for grounding and bonding. This article covers everything from the size and type of grounding conductors to the installation of grounding electrodes. It's important to consult the NEC when designing or installing a grounding system to ensure that it complies with all applicable requirements. Grounding systems should be inspected and tested regularly to ensure that they are functioning properly. Ground resistance testing can be used to measure the resistance of the grounding electrode system to ground. This testing can help identify potential problems such as corroded connections or damaged grounding electrodes. If the ground resistance is too high, it may be necessary to repair or replace the grounding system. Understanding the basics of electrical theory is crucial for understanding the importance of grounding. Electricity always seeks the path of least resistance back to its source. In a properly grounded system, the grounding conductor provides a low resistance path for fault current to flow back to the source, tripping the circuit breaker or fuse. Without a proper grounding system, a fault current may find other paths to ground, such as through a person's body, which can result in electric shock. Grounding and bonding are often used interchangeably, but they are two distinct concepts. Grounding refers to the connection of electrical equipment to the earth, while bonding refers to the connection of metallic parts of the electrical system together. Both grounding and bonding are essential for electrical safety. Effective grounding also contributes to electromagnetic compatibility (EMC). Proper grounding minimizes electromagnetic interference (EMI), which can disrupt the operation of sensitive electronic equipment. By providing a low impedance path for unwanted currents to flow to ground, grounding helps to reduce EMI and improve the overall performance of electronic systems. In industrial settings, grounding is particularly important due to the presence of heavy machinery and complex electrical systems. Industrial grounding systems must be designed to handle large fault currents and provide reliable protection against electrical hazards. Regular maintenance and testing of industrial grounding systems are essential to ensure their continued effectiveness. Different types of grounding electrodes are available, each with its own advantages and disadvantages. Ground rods are the most common type of grounding electrode, but other options include ground plates, underground metallic water pipes, and concrete encased electrodes, also known as UFA grounds. The choice of grounding electrode depends on the specific application and the soil conditions. The size of the grounding conductor is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of grounding conductors based on the size of the circuit conductors. It's important to use the correct size grounding conductor to ensure that it can safely carry the fault current back to the source. When installing grounding conductors, it's important to make sure that all connections are tight and secure. Loose connections can increase the resistance of the grounding path, reducing its effectiveness. Use appropriate connectors and tools to ensure that all connections are properly made. In some cases, it may be necessary to use exothermic welding to create a permanent low-resistance connection between grounding conductors. Exothermic welding involves using a chemical reaction to melt the conductors together, creating a solid, continuous connection. Grounding is not a substitute for other safety measures such as proper insulation and lockout/tagout procedures. These measures are also important for protecting people from electrical hazards. Proper insulation prevents current from leaking from electrical circuits, while lockout/tagout procedures ensure that electrical equipment is de-energized before it is worked on. It is important to consider the impact of corrosion on grounding systems. Corrosion can degrade grounding conductors and connections, increasing the resistance of the grounding path. To minimize corrosion, use corrosion-resistant materials and apply protective coatings to grounding conductors and connections. In coastal areas, where the air is salty, corrosion is a particularly significant concern. In agricultural settings, grounding is important for protecting livestock from stray voltage. Stray voltage is a small voltage that can be present on grounded equipment, such as water troughs and fences. Stray voltage can cause animals to become agitated and may reduce their productivity. Proper grounding can help to minimize stray voltage and protect livestock. Grounding systems should be designed and installed by qualified personnel who have the knowledge and experience to ensure that they are safe and effective. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. Always de-energize electrical circuits before working on them and use appropriate personal protective equipment, such as insulated gloves and safety glasses. Grounding is a constantly evolving field, with new technologies and techniques being developed all the time. Stay up to date on the latest developments in grounding to ensure that you are using the best practices for electrical safety. Consult with electrical engineers and other experts to learn more about grounding and how it can be used to improve electrical safety and performance. Consider the specific needs of your application when designing a grounding system. Different applications have different grounding requirements. For example, a hospital has different grounding requirements than a commercial office building. Tailor the grounding system to meet the specific needs of the application. Grounding is not a one-size-fits-all solution. In addition to the NEC, other standards and regulations may apply to grounding systems. For example, the Institute of Electrical and Electronics Engineers (IEE) publishes standards on grounding for specific applications such as power generating plants and data centers. Be sure to comply with all applicable standards and regulations when designing and installing a grounding system. Grounding is an investment in safety and reliability. A properly designed and installed grounding system can protect people from electrical shock, prevent damage to equipment, and improve the performance of electronic systems. The cost of a grounding system is small compared to the potential consequences of electrical hazards. When troubleshooting electrical problems, always check the grounding system. A faulty grounding system can cause a variety of electrical problems such as flickering lights, tripped circuit breakers, and malfunctioning equipment. A thorough inspection of the grounding system can often identify the root cause of these problems. Grounding is an essential part of any electrical system, and it should never be overlooked.